Good afternoon. My name is Jonathan Gladstone. I'm a member of the Board of Directors of the Computer Measurements Group. I'm here to welcome you to today's webinar. Brent Phillips and his team from IntelliMagic are sponsoring today's session, titled Unlocking Visibility into ZOS Disk and Tape Environments. If you have any questions about today's session, please use the chat section at the bottom of your screen. The IntelliMagic team will handle those questions either in line or at the end of the session. Thank you.
Great, thank you, Jonathan. This is Brent Phillips. Thank you, everyone, for joining us for this time. I appreciate very much you spending some time with us, and we want to make it as valuable as possible for you. So if you do have questions, we will be monitoring those questions. If we seem to ignore it for a minute, maybe it's because we see it and we know we're going to answer it in just a few slides here, but there's also some time at the end for questions as well. So I'm the Managing Director for IntelliMagic in the Americas, have a systems programming background years and years ago, about 30 years ago actually, been working in the mainframe environment ever since and love the platform, love the environment. I've got two really deep experts with me today. Lee LaFries is going to be doing part of it. Let me just actually advance the slides here. There we go. So I'm going to actually cover some intro on kind of what we're doing and how it's different than the way we've always done things in terms of mining the data to get better intelligence out of it for the platform, in particular for the disk and tape platform in this, or part of the infrastructure in this presentation. So Lee is going to do a deep dive kind of example and demo on the disk and replication to illustrate, give you kind of a flavor of what we're talking about in that context. And then I've got David Hagan on the line as well. And so he's going to give a couple of examples and demos for the virtual tape and tape infrastructure. So with that, we'll get started. The general concept here is how do we get better intelligence to improve how we operate the part of the infrastructure that we're responsible for. So if you've seen our stuff around, you've probably seen this old antiquated lighthouse there, and you know, it's kind of inspiring to us actually. I mean, we like the idea of this signal to know where you really were. As a ship captain, without the stars to navigate by, all you had was a compass. I mean, it was pretty important to know where you were and where the hidden dangers were, and that's why these expensive lighthouses were built in the day. Of course, they're outdated today. In 1986, a new technology came to provide far superior intelligence about where you were in the form of GPS being released to the commercial sector. But it's still interesting. So how is that relevant to what we're talking about today? I mean, this is what inspires us to create better intelligence out of the RMF and SMF data. We think there's a lot more that you can obtain that's very useful to provide you with the intelligence that you need to make good decisions. And so if we're talking about human decision making in IT operations, I mean, there's back in the last century, H.A. Simon created a decision-making model that's been widely used since then, and he talks about three different things. The first thing is just the process of intelligence, identifying a problem, or it could be an opportunity as well, and sometimes those two mix just based on where you're at in the cycle. If you see it soon enough, it might be an opportunity. If you wait too long and see it only after a production problem, it's a problem that you have to find out. So identifying the problem and collecting the information that's relevant to it is kind of the intelligence status. And then you create alternative solutions based on the intelligence that you have about what's really going on, and you make a choice. That's kind of an easy, common sense description of the decision-making process. So we like to talk about the intelligence as part of that phase. How can we make it easier to deliver to you, the IT staff that's responsible for operating this part of the infrastructure, you know, better intelligence about what's really going on, identifying those problems at the earliest stage possible, and giving you all the relevant information there, because that's really what you use to design a solution to what's going on. So that's kind of an overview of the context of what we're talking about. And one way to look at this is just to compare kind of the status quo way that we report on the SMF data today compared with a new approach to get better intelligence out of the data. So in the first step of the process, we talked about identifying the problem. Today, it's pretty common everywhere we go that there's a lot of firefighting. There's more firefighting, and you really look into the data after a production problem has already been reported. And from our perspective, it would be really nice and more strategic to be able to get some visibility about what's going on, the risk, as the risk of a service disruption is growing in part of the infrastructure. How can we be notified of that to get that early warning and deal with the situation before it becomes a production problem? And collecting more information about it. Today it's a pretty slow and incomplete process to use static reports, which only really provide partial views. The SMF and RMF data most of the time will give you only a logical view of the workloads and what's going on, response times and whatnot. But it's not interpreted in the context of the physical hardware that's running those workloads. A modernized approach will provide fast information, so you don't have to do any coding and gathering of reports and manipulation of data, and a deep view into really what's going on and the interconnected views with rated metrics about, is this good or bad based on this particular type of workload running on this configuration of hardware, and is it in line with the best practices that we've established? If you could have intelligence that can flag something for you that violates any of those characteristics, that's extremely powerful and beneficial for the decisions that you make on operating the platform for high availability. So creating a solution from that, with the disparate reports that are not perused proactively on a continual basis, usually it's just harder and takes more amount of time to spot the root cause and to design a solution for it. So if you use some artificial intelligence techniques to bubble up what's important in the data and present it to the analyst, then it can highlight really what you need to look at, what it means in the context of what's going on, so you can create a solution that's most appropriate to deal with the issue at hand. So the consequence of all that are decisions that are more risky. If you're being asked to make decisions about operating the platform and dealing with issues without having a complete picture of what's going on, it's not really fair for one perspective, but it's also going to take more time, and it's going to take more data manipulation and so on and so forth, and that has some consequences to the business applications that you're supporting. Whereas with a modernized approach and this built-in intelligence creation, there's less risk, faster problem solving, and don't have to spend half the day preparing the data and generating the reports to try to figure out what's going on. So this chart is actually a good chart for presenting up to management about why a new approach is necessary to get some justification for this, because these are real issues, and it's a common theme that a lot of executives in the IT organization are dealing with on how to leverage more modern techniques on getting better intelligence out of the data that translate into operational decisions that are easier, faster, and better and safer. So the question is, how do we do it? How to get that better intelligence out of it? Well, this is kind of a marketing thing. AI cubed is availability intelligence. You see that on our footer here. We've talked about that for a number of years, how to get more intelligence about the things that will predict high availability or the risks that will disrupt availability. That's what we're talking about. For your application infrastructure, leveraging applied artificial intelligence techniques. So there's 3 AIs in there. That's what we're talking about. And this is our focus. This is what we want to show you in the demos today, how to create dynamic intelligence automatically out of the data that allows you to improve the availability using a superior and early insights into the performance and configuration issues that can disrupt the availability for key applications that are running on the infrastructure. We're not really going to talk about it in today's session because we're just focused on the disk and the tape parts of the infrastructure, but we do have some application groups reporting that can show you across really end-to-end on the mainframe infrastructure, how are these infrastructure components handling these applications, which has been well received in our customer base, is this application infrastructure idea, getting visibility there. So to make this really, different in terms of the results and the impact on your organization, I mean, really, any modernization of how you approach this should answer some key questions like, what's good and bad across the entire complex infrastructure? We do this with something called exception charts that you'll see in dashboards and rated metrics rating the metrics based on the type of workload it is and the hardware that it's running on, the specific configurations. Is it good or is it bad? Applying some best practices to rate the metrics and serve up what's good and bad, as opposed to looking through tons of reports that nobody has time to do to try to spot, is there something going wrong? That's why we tend to only look at these things and after a problem is already broken out. Also, what related metrics are relevant to the context? So you'll see some side-by-side mini charts, what we call, as you click down on the dashboard and see these metrics are relevant. You want to see these things side by side. So anticipating what you're going to want to see is important, and where you want to go next. Pre-building these drill downs to be able to get to the root cause and understand what's going on. So we have built-in recommendations as well. So hopefully you'll see some of that in the demos that Lee and Dave will do. Those are some of the concepts. The thing that makes it different in what we're doing is applying some techniques. And this is important to point out because there's a lot going on in the AI area these days. Most of the solutions out there in what you might call the IT operation analytics area, ITOA, are leveraging statistical analysis on the data to recognize anomalies, to see correlations in the metrics, and try to identify problems that are already happening. And there is some significant value in that. But from our perspective, if you really want to get the kind of value we're talking about, this intelligence that's usable and actionable, the solution that analyzes the data has to have ZOS-specific expert knowledge built into it about the types of workloads, about the best practices, and about the specific characteristics of the hardware that you're using to run those workloads. So doing this, you can actually derive some new meaningful metrics out of the raw SMF data that you don't have just out of the RMF data. You can normalize the data, properly correlate it across different environments, different time zones, so on and so forth. You can automatically apply this knowledge to rate them as good or bad. For example, in the storage environment, what are the capacity limits of the internal components there, like port throughput? If you know that and you can apply that, you can continually measure that and raise a flag as it's approaching a place of utilization, a level of utilization that it will start to introduce delays into the environment. So you can see that early. That's a great example of what we're talking about. The best practice, as I've mentioned, workload balance across the resources. ZOS is actually excellent about masking some issues and maintaining service levels even if you lose some redundant components. But that's something that you want to flag and see even though service levels are fine, because if you lose the second link, you're really in trouble. So you want to see that early. And then the relationship and interaction of the logical and physical resources. This is also key for really understanding what the data means regarding risk to the availability levels, to the risk of having some kind of service disruption crop up as your peak workloads drive different parts of the infrastructure. So it's really a difference of looking into root causes and monitoring the root causes, so not just the symptoms of a problem. So here's a kind of a diagram of some issues that for a disk storage array in the mainframe environment. And the lag measure is what you might call a symptom, right? It's very easy to set a threshold and alert when response times go high. But first of all, is it a significant workload? And when that goes high, I mean, you don't want this alarm going off all the time, right? Then it becomes meaningless. So it's really not that useful, because when it really goes off, then a problem is already occurring in the production environment. If instead you want to look at the things behind the response time that drive or predict response time, you're going to get much closer to being really early warning and predictive in what's going on. So I don't think we have the time to go through these in detail, but the adapter utilization is an example I've already mentioned on the front end of the storage array. There's different things on the back end, or there's balance between arrays or within arrays. All these things can be programmatically analyzed on a continuous basis across the entire environment to be able to serve up this kind of intelligence about what's going on. And it requires this built-in expert knowledge about the hardware, about ZOS, and so on and so forth. So another way to look at this, if you like kind of charts, is, you know, what are the high-value metrics that are predictive in nature, and how hard are they to get? I mean, some things are very easy to get, like response time. Everybody knows the response times for different workloads on data set basis, volume basis, sysid basis, whatever. Throughput is actually a better indicator of how much work that this subsystem is doing and gives you a better understanding of what's going on. Then there's things like utilization. I mean, for these ports, what percentage of utilization do these workloads during my peak period represent? And even more value in terms of predictive nature is how close to the edge are these components in terms of the workloads that we're running on them, you know, to introducing delays into the service environment. But of course, it works out that the things that are the greatest value are the hardest to obtain, and that's really why they're just not looked at on a proactive basis until a problem is already happening. So in a modernization of a solution, we really want to move all of these up to the easy to get, far right, and increase the value as much as we can in them. And we believe we've done a great job at that with our approach to this. So some of you might be thinking, okay, well, how does I/O response time, how does that increase in value? Well, it's actually a rated metric for us, and we see it in the context of other things that are going on. So you'll get a glimpse of that in the demo, I think. So we cover, really, we've been doing storage for 25 years now on the mainframe, from starting in performance modeling and then analytics about monitoring the environment. So here's just a brief view. You can get a copy of the slides if you like afterwards, and this shows you some of the records. There's other kinds of data sources we process as well, but it's very complete, robust visibility into the disk and replication and tape and virtual tape environment. We do, by the way, I know this is a storage webinar, but just as a FYI, we support the systems area as well with all of these records, the legacy records on the left that everybody's been reporting on for years and years. There's newer record types that have been emerging that we also support on the right. EDC is the compression cards have been popular. SMT is coming, and all these things with the asterisk in the lower right there coming in our release next month, and getting some good input and feedback on those. So down the road, we're going to be including as well TCP/IP has been getting some good reviews from the early testers of that. That's coming in March. OSA channels, the SMTs on the zips, and the SCRT kind of reports out of the 89 records. So we're doing a lot of things. Our ambition is actually to be the only analytics solution you need for the performance and availability requirements out of the RMF and SMF data. And we've made good headway on that over the decades, actually, that we've been working in this environment. So one last slide before we jump over to some of the demos and examples is just to help you understand what we're talking about in terms of a product. It's called IntelliMagic Vision. In particular, there's a module for disk and replication, and then another module for tape and virtual tape, and then a third module for systems as well. But we're going to be primarily showing you the disk and replication module with Lee's demo, and the tape and virtual tape module with Dave's demo here. It's available to install on-premise, but the best practice is really to leverage the software as a service. So this is in a secure data center. We host the database. We manage the database. You don't have to spend time on software installation and database management, so on and so forth. There's a lot of advantages, and it drives up the value that you can obtain out of it. And it's really a good problem to solve with the software as a service approach, because there is no personal information in the data. It's metrics about the infrastructure, performance, and configuration. So from a security standpoint, it's usually not a problem, even with some of the big banks that are our customers. It also makes it easy for different roles within your organization to get access to customized intelligence about the part of the infrastructure that they're responsible for. And in addition, it makes it easy. A lot of our software as a service customers will get some advice from through 10 hours a month of professional services from our experts. We've got some very deep experts on staff. And we're seeing things at companies like your peer companies about what's going on. There's been some very interesting problems we've been instrumental in solving. And if you can learn from that experience, it's really nice to have access to somebody that's familiar with your environment and data and can provide some additional input when things happen. All right. So now we'll get into the rest of the webinar with some demos. Lee, you're on. I'm going to switch the presentation over to you.
Hello, can everybody hear me? I gotta show my screen here. This is Leela Fries. I'm a senior consultant at IntelliMagic. I've had a pretty long history in the enterprise disk storage area. So I'm going to take you through the early parts of this demonstration, and then I'm going to turn it over to Dave, my colleague Dave, who will show you some of these practical examples of IntelliMagic Vision in action. So the first thing I'm going to talk about are dashboards and ratings, and show you kind of how our dashboards work and our rating systems works, you know, using some of that embedded intelligence that Brent was mentioning. Then I have an example, a very simple example, but very powerful, of a high connect time problem. You know, we've got a mysterious case of expanded connect time, and we're going to show you how we can dig into it and solve it. Then I'll take you to some ZOS replication, looking at global mirror RPO spikes, where we have that kind of situation, and how we can use IntelliMagic Vision to diagnose and solve that problem. Then I'm going to turn it over to Dave, and he'll take a look at you know, how you can use IntelliMagic Vision to understand the logical to physical mapping of ZOS tape libraries. And finally, we will apply IntelliMagic Vision to ZOS tape management catalog analysis. So first, dashboards and ratings. You know, this is really where we show the embedded expertise that you have in IntelliMagic Vision. I'm going to do a brief demo here to show you what the dashboards look like and explain them a bit, and also show you how ratings are presented. So I'm going to have to switch over here to the actual software. So this is what the software looks like, and this is an example of a disk storage system dashboard. We actually have dozens of dashboards available for much more than just disk storage systems. All of our areas have dashboards associated with them, but this is a good example to use to show you the lay of the land. The ratings in the dashboard are based on embedded knowledge about the hardware that's being monitored. In this case, a disk storage system. We actually have 4 disk storage systems that we're monitoring here along the left. They're listed by name. Across the top, we have the key metrics involved that we're monitoring and rating. We also notice there's a border around this dashboard. It's a yellow border indicating that we do have some what we call early warnings. The dots in this dashboard indicate something. The green dots indicate that we have a healthy situation. Everything is good. There's no issues. The yellow dots, you can see we have 2 yellow dots on this dashboard, one for this storage system and another one for this other storage system. Those yellow dots indicate that we have an early warning condition. You know, things are probably not being affected just yet, but you're in danger of, if things get worse, actually affecting your overall applications. We also have a numerical rating up here. This is on a scale from 0 to 3. In this case, the rating is 0.14. 3 would indicate that you're always in what we call a performance exception zone. That would be for a red rating. And then 0 would indicate you've never even exceeded an early warning for any of the intervals that you have data for. So this is you know, giving you a good flavor for how the rating system works. The size of the dot is proportional to the severity of the warning or exception. You also notice a couple of blue dots over here on the left. For example, I/O rate, we have blue dots because we really don't have an opinion about a high or low I/O rate meaning anything. It's really there just to show you the intensity of the I/Os. There's no health associated with a high or low I/O rate. These other metrics, though, up here at the top, all have you know, health associated with them. So from here, we're going to drill down, and we're going to show you a multi-chart for one of the storage systems. All you have to do is click on one of the storage systems, and you get this multi-chart. So now all those metrics that we were looking at before, all these key metrics are now in chart form. And in this case, maybe the connect time is the one we want to look at because that's the one that's yellow. So let's take a look at this particular multi-chart. Now we see the connect time graph for you. Let's just go back and look at the other multi-chart first. Actually, I'm a little out of order here. So I can go down here and I can change to a different storage system easily and get the multi-chart for that storage system. In this case, my yellow metric is read hit percentage. I'm going to bring that chart up first. So the read hit percentage is an example of where we have what are called fixed thresholds. These are built into the product. This is the embedded knowledge that we've been talking about. In the case of read hit percentage, the lower the number, the worse it is. So the thresholds are here at the bottom. This dark shaded area is what we call the performance exception threshold. If you're down in that zone, you're not achieving what your hardware is capable of. This zone up here is that early warning threshold I talked about that produces yellow ratings. So you do see that we're frequently in this yellow zone, often enough to raise an early warning, and that's why the rating is what it is and why the border is yellow. And then up here is the healthy zone where things are good and you're performing as expected. So these are fixed thresholds. They don't change over time. Let's go back to the other dashboard here and the other multi-chart. And we'll go back to our connect time graph. So with the connect time, we have a different kind of threshold. Here we have what we call dynamic thresholds. The dynamic thresholds are really based not just on the hardware capabilities, but also on the variabilities of the workload over time. For example, the connect time is not just based on what the hardware can deliver or the speed of the channels. It's also based on the workload attributes such as the size of the IOs or the protocols in use for those IOs. So that's why you see the wavy lines on both the yellow and the performance exception zones. And notice that those wavy lines kind of follow what the actual connect time is. Sometimes we're under, but we're often enough in this early warning zone that we're raising a flag and calling this an early warning. So that's part of that embedded intelligence that we're talking about. So from here, we could drill down further, and that's where all these things up at the top are drill downs that are available with just a click. So you say, okay, I'm getting some high connect time. Is it isolated to a particular area? So in this example, I can click on SSID, and I can drill down from there. And indeed, I'm able to see that one SSID has been flagged as the culprit for this high connect time. And indeed, that SSID is rated worse because it's got some pretty high connect times and is in that red zone. So we're very quickly able to narrow things down and determine, precisely where the problem is coming from. So this is the demo portion. I'm going to return to my presentation and show you some of those examples that we were talking about. So this is the first case study I'm showing you. It's an example of how IntelliMagic Vision can help you respond to performance issues, in this case caused by software changes. The embedded expertise in the dashboards highlight that there has been a sudden increase in the connect time. The patterns are used to determine exactly when the problem began, and then by drilling down to specific volumes and consulting change logs, it was easy to determine that the problem was being caused by a newly released SQL query that, once fixed, the connect time issue was eliminated. So let me take you through this example. So the customer is using IntelliMagic Vision to regularly monitor their storage. Before the problem began, the connect time was healthy per the dashboard. However, here we see on January 31st that the connect time changed to yellow. This is the first evidence that something has changed. Indeed, on the next day, February 1st, the dashboard had turned red. So now we have an issue with connect time, and it's likely causing other problems. Notice also that the response time has turned yellow. So the connect time is making a big contribution to the response time here. If we look at the charts, the underlying charts behind the dashboard, we see that the overall response time is behaving in a rather periodic way. We're seeing these big spikes, definitely going into the yellow quite frequently. And the connect time is even into that red zone. It's into the performance exception zone, and it's driving that red rating on the chart. So we definitely need to investigate root cause here of why we're seeing this high connect time. And this is for the overall storage box. We haven't drilled down yet to really find where the problem is, but right from a high level, we're seeing that there's a problem overall on the storage box. So now we can drill down and we can expand the time frame. We can look at more days than we were looking at before. We can go back to the 29th to see where the change occurred. Here we can see that there are specific volumes that are driving much of the connect time issue. We can see that these volumes have higher ratings. For example, this one here, and this one here, and this one here have pretty high ratings, and this one over here as well. So we're able to identify the volumes that are making the biggest contribution to this connect time issue. So indeed, by consulting logs, it was found that at about the same time that this connect time issue started, a SQL query had been introduced and run against the data sets that were on the actual volumes that were affected. So it was easy to identify the problem because of the embedded intelligence in IntelliMagic Vision, and by finding some patterns, we were able to notice these big spiky behaviors. And by the time they got it through change control, it was a few more days, and finally on February 14th, the connect time indeed is reduced down to back in the range where it was before the SQL query was introduced. So this is definitely pretty clear cut that the SQL query was at fault. So what does this all mean? What were the benefits that were derived from doing this analysis? It did take some time to fix the query. It had to get it through change control, but after the fix, we did get things back down to normal. So what are the benefits? The software flagged the issue before the staff even knew what was going on. So it was proactive. The built-in thresholds were very instrumental in determining what is good versus bad behavior. You're just seeing a connect time and noticing it was a little higher than before. Is it good? Is it bad? How bad are things? The software is able to tell you that right away. It's easy to find a pattern and find when the problem started and fix and make sure that the fix really worked. And finally, the drill down helped you identify specific volumes that were related and help you find the root cause pretty quickly. So that's kind of the operational benefits that were derived from using IntelliMagic Vision in this case. Okay, let's move on to the next example. This is for replication. And in this case, what was happening was we were seeing some global mirrored RPO spikes. Now, replication is pretty tricky. It's one of the harder problems that you face in managing your storage environment, especially asynchronous replication. With the asynchronous replication, the disaster recovery site is by nature always going to be somewhat behind the primary. This is usually acceptable, but if things fall too far behind, the mirror could be suspended, which could be an outage for you. So you have to really keep an eye on things and make sure that if you do have spikes, that they don't get out of control. This case study is going to show you how IntelliMagic Vision can be used to provide the visibility to the status of global mirror replication in a globally dispersed parallel sysplex environment, or GDPS. Data about the global mirror sessions is recorded in SMF Type 105 records, which IntelliMagic Vision can analyze. By looking at patterns and drill downs, the root cause of this issue was determined pretty quickly. So here's an example of visibility you can get by using IntelliMagic Vision into global mirror sessions. We notice in this chart that we're seeing some spikes in the RPO, or recovery point objective, for one of the global mirror sessions. It's only the blue sessions that's really having issues. The other sessions look pretty healthy. So what we were able to do, one of the features of IntelliMagic Vision is it can chart things by day of the week. So we charted it by day of the week here, and we found that these spikes are typically happening over time on Sundays. Sunday is when the spikes are typically occurring, and that's when the issue is happening. So that pattern recognition is something that IntelliMagic Vision really facilitates. From here we can do some drill downs. We can look at more than just the RPO. We can look at how many out-of-sync tracks we have in the session. And we see that the out-of-sync tracks kind of corresponds to that RPO spikes. So maybe the storage is overloaded. Maybe there's some issue in the infrastructure that is contributing to this out-of-sync track situation. Indeed, we can then drill down further and see, are there any volumes being suspended? And we do see them being suspended on one of the storage systems. Now note that this storage system, or DSS, this storage system, is a Metro Mirror target in a Metro Global Mirror configuration. So it's receiving data from a primary storage system, and then it's sending it remotely off to the Global Mirror target. So that's important to know in this example. So we went further and we looked at two things. We wanted to see how much replication data is coming into this storage box of interest from the primary. And what we see is some pretty hefty spikes. We're seeing spikes, typically, well over 1,100 megabytes per second. So we're seeing pretty high spikes in activity, and in some cases, like here, they're sustained in that 900 to 1,100 megabyte per second range. Then we look at the send. In other words, how much data is this box sending to its global mirror secondary at a remote location? And we only see that throughput up in the 400 megabyte per second range. So there's definitely an imbalance here, and that's explaining why things are getting so far out of sync. You're putting a lot more data into this box than you're able to send out of the box. So the issue was found and flagged quickly. The problem was lack of bandwidth. You didn't have enough bandwidth to send the data out of the box as you had capability to send data to the box. So you had an imbalance here, and it was easy to see when the problem occurred and what caused it, and by drilling down you could find out the specific storage system that's affected and the fact that it was a bandwidth issue. By increasing the provision bandwidth between that storage box and its global mirror target, the problem could be solved and the RPO spikes could be eliminated. So I think I'm going to turn things over to Dave Hagen now, who's going to talk about ZOS tape.
Thank you, Lee. All right. Peggy doing request control. I don't know who Peggy Lee is. Hold it. Let me show my screen. There we go. My portion of the presentation involves ZOS tape. We're going to shift the focus there. Thank you, Lee. Our tape product reports on the tape activity seen by ZOS and then looks at some specific hardware platforms to rate performance and look behind the scenes. We presently support all native tape activity on the ZOS platform, as well as virtual tape environments presented by Oracle VSM and the IBM TS7700. We have EMC DLM support being developed as we speak. I don't want to go into all the details specifically on this chart. Let's suffice to say that we have 4 specific data sources that we're interested in. We look at the SMF data coming from the ZOS platform, all LPARs, in a sysplex environment, and we can report on multiple sysplexes. We look at the TMS, or the tape management system information that's available. We'll take extracts out of a variety of places and actually place that also in the database. We look at the HSC events coming from a VSM, an Oracle VSM, and this is SMF data, again, being recorded on the VSM's behalf, as well as the BVIR data coming from a TS7700. Knowing all the various data sources that we use, it gives you an idea of what the capabilities of the product are. So far in the presentation roadmap, Lee has presented the high connect time problem and the replication problem as far as disk is concerned, and now we're moving on to the ZOS tape. I'm going to show you a physical to logical mapping, as well as some of the tape management catalog analysis we just recently added to the product. So now we're talking about visibility and embedded expertise. So this is the bridge from the physical to logical activity. And I'll start up the demonstration. Let me show you the dashboard for TS7700. We have 8 dashboards available in TS7700. Capabilities are very similar to the disk product. As you can see, the first 5 dashboards, the first 3 dashboards are rated green, so there's no issue as far as cache, virtual drives, or throughput. But we are seeing issues with utilization, with replication, with the back end. And then the migration and recall are no issue for this particular environment. I'd like to show you a dividing point between the first 5 dashboards, or the first 5 reports, and the last 3. A TS77 environment will always have the first 5 dashboards, but the TS7740 with a tape backend will only have the last 3. So that's kind of a little method to our madness in terms of the organization of the dashboards on this particular chart. But the first place we have is a problem with utilization, so I want to show this to you. Looking at utilization, we look at first at the grid level. If you had multiple grids, we'd be showing multiple rows. But in this particular situation, there's one TS7700 grid, and it's having a problem with CPU percent in terms of CPU utilization. So if I do the drill down, I'll go from here to clusters, and now I'm looking at a variety of clusters, and I see I've got 2 clusters within the grid, and again, both clusters are having an issue with the CPU utilization. Now, if I were to click on the cluster 0, for example, it'd show me the time charts. But for the purposes of demonstration, I want to change the order a little bit and actually look at the detail in CPU 0, give you a little characteristic of what's going on there. I also want to change my view so that I can maximize the chart. So now you're seeing a maximized chart. Let me go into that. Hopefully you can see that I am showing a maximum value now that when it peaks, it hits 98%. And the time of the maximum value is going to be at 3:15 a.m. We have a 98th percentile of 95%, 95th percentile of 92%, and the average is at 58%. So, and this gives you an idea of the specific readings we have at all the variety of different intervals. Now, we don't have any particular information concerning maximum or the average disk utilization, and the reason for that is that this particular TS7700 is a microcode level 2.1, and those fields are not being reported, so it's not of any great concern. Let me back up one now. CPU utilization, let me show the chart. Oh, go back. Changed it back to time charts. We'll find the mini chart. This is the chart for CPU utilization. As you can see, we've got a lot of white space involved. The thresholds are only exceeded at certain peaks and points in time. And a lot of times with tape activity, if you're looking at a midnight to midnight, it'll look bimodal. You know, it'll start high, basically go down during the day, and then come back up in the evening. The secret to trying to get CPU utilization up is certainly whatever I can schedule and move into the white space. Otherwise, I'm looking at a processor upgrade in order to be able to handle the peaks that I'm seeing. One of the things that actually gets involved when I'm using CPU is, and things I can schedule, at least in the TS7700, is something called reclamation. So I want to look at that for a second. Let me go back to a normal size chart, and we'll go to the back end. And we'll look at what kind of reclamation is going on with this particular cluster. And as you can see, these are all the different back-end performance charts. But if I'm looking at reclamation, this is the physical reclamation mounts. We're not doing any reclamation in this particular point in time, so this is a bust in terms of trying to find a problem, or at least something I can schedule out of the way in terms of CPU utilization. Reclamation is not going to fix the problem. So going back to utilization again, I want to show you a little bit about some of the detail. We also have the ability, rather than to go drill down from the dashboards, you also can go straight into the reports. Here's TS7700 system, and if I look at system, I'll see that, yeah, here's my CPU utilization, and these are all the various different peaks and valleys, but this is without the, this is for the grid, and if I drill down further, I'll have both grids, or both clusters within the grid, and then if I come here, if I go to identify, isolate, I'll see this particular grid. So this is the same chart you saw earlier. One of the things that correlates very highly with CPU utilization is the throughput, the cache throughput. So I actually bothered to create a graph that maps both variables together. And here's the red line is the total CPU utilization percent, and here's the total rate of all cache throughput going on within the cluster itself. And as you can see, these are two variables are very highly correlated. So whenever there's activity going on in the cache, that's when the CPU is going to get busy, and that makes sense. So if I go and I actually look at the cache rate, which is another graph I have available from the system view, I can look down on the clusters, click on the cluster, and I can look at the cache flow that's going on within the cluster. This tells me all the variety of different activities that are going on within the cluster itself. And what I see is virtual device read and write, which is basically activity coming in from the host, is fairly high, and I've also see that the outbound copy rate is fairly high. So what's happening for the most part is I've got a lot of activity occurring from the host, as well as additional activity going on from a copy or replication perspective. And those are the things that are driving the utilization at that particular peak. If I want to go one step further, let me go to the CPU utilization and actually click on the peak. And one of the things I want to look at, let me go to clusters. I can actually see the mounts at the time. Now this is the part that I wanted you to pay special attention to, because we are now going from a physical, which is the TS7700, into a logical view, which is these are the mounts occurring at the time, plus or minus 30 minutes within this particular interval. So this is the actual workload that's running in that TS7700 cluster at this particular point in time, plus or minus 30 minutes. As you can see, you've got the vol ID, the system it's running on, the unit that it's actually allocated, the type of media, the job and program that was running, data set names, whether read or write activity, whether it's a specific or scratch mount, etc. So we are listing all the specific detail of the workload going on at that particular moment in time. Our feedback from initial customers from this particular function is that this particular activity could take them almost weeks to be able to do, and we're capable of doing it very quickly in the product in a matter of minutes. Come out of this, come back to the presentation. So operational benefits of being able to go from the physical to the logical. Certainly we're showing you expertise. The software knows that there was an issue. It's highlighting and providing you ratings concerning the thresholds being exceeded in a variety of different dashboards. It gives you visibility to say it's pretty easy to assess, how busy the CPU is, when it's more busy than others, where you might be able to move scheduling activity if that's actually an option to try to avoid the CPU upgrade or hardware upgrade. And it gives you certainly the drill down capability so you can identify the ZOS workload that was active around the time of the event. So we're giving you the ability to hopefully identify and fix the problem. All right, the next thing I wanted to show you was something we've added to the product fairly recently. It's our Tmc Trend Analysis. And the whole idea behind this is trying to help customers identify who's using up all my tapes. So we are looking to help you identify certainly patterns and give you drill down and visibility into those types of situations. I'll talk about that later. IntelliMagic Vision supports 5 different tape management catalogs, so we support these 5 products: CA1 RMM, Zera, TLMS, and Control-T. We use an IBM tape tools utility called FormCats, and what FormCats does for us is it transforms the TMC extracts into a common format that we load into tables for interrogation. In IntelliMagic Vision for COS, we support something called volume groups. We've always done this for SMF data reporting for application activity. So we could tell people, for example, here's the activity that we see for HSM, or here's the activity we see for HSM migration level 1. Here's the activity we see for ZOS utilities. Here's the activity we see for backup, that kind of thing. And we apply those definitions then to the TMC data to allow us to be able to give us workload categorization of the TMC. And we're of course, loading millions of information about millions of volumes of tape volumes. And in this process, basically, we're also categorizing the workload. So you can then say, all right, here's the value I have for this particular type of workload that's going on in my environment. An example of this would be certainly the volume group backup, and I've got the program as ADR DSSU or FDR, and that being that DFDSS or FDR being the backup utilities. The volume groups allow for categorization by job, by program, by dataset name, by DD name, device, or media. But the program or DSA are certainly the most useful ones that we can have for TMC analysis, because those are common elements in just about any TMC record in terms of here's the program that actually created the data set, or here's the actual data set name. So the TMC data that we load into the database is actually a point-in-time capture of the library. We don't keep, interval information about that. It really, the problem is it really doesn't have any particular timestamp when we load it. So when we load the data, we actually load it with the timestamp of the accompanying data that's with it, the last interval. We keep summary data. We will summarize this data, though, by volume group for yearly trending. And then the trend volume count, we also trend the volume counts. We'll be trending the megabytes by volume group, those kinds of things. So that's the TMC analysis. Let me go into the demo, and I'll show you what it looks like. This is where we left the demo. Let me come out of here. So the idea is saying it's in the trending yearly place, the report set. There's the tape volumes. And this is not particularly interesting because this is a single day. I don't have a lot of days, so I need you to use your imagination a little bit to think, well, what if this were, weeks or months worth of data? I'd hopefully be able to see much more trending going on. Let me apply this change. And now we'll be looking at multiple days in order to try to see or spot a trend. The first trend I can spot right away is the scratch pool, which is actually a very pleasant trend, in that I'm seeing, the scratch volumes actually increase or improve. This is nice, but I think I would prefer to see this as a line chart rather than a stacked bar chart. So I will customize this and change it to a line. And what I'm seeing is the ECCST, which is the virtual tape volumes in this environment, basically went from a scratch count of approximately 6,462, and the ending value is somewhere around 738. So that's kind of a nice bump. Bumps like that are going to happen periodically from time to time, in intervals whenever, scratch, whenever I run the actual housekeeping to be able to bring things, start scratching tapes, etc. So this type of bump isn't so much important. What we're concerned about more or less is saying I don't want to see a downward trend, certainly in the scratch. And the other piece is I want to be able to I don't want to see a downward trend in the scratch, and I want to be able to see, all right, if I do have a problem, where is it? So here's the actual volumes that I have available to me, and I have almost 250,000 volumes in this particular environment. The largest use of volumes is actually in a group called Other. Now, one of the things I can do is a drill down where I say, all right, I want to see what Other looks like, and it will give me characterization then of all the different programs that are used in this Other. And I see sync sort as one of the larger programs that's in use. Although these are flat lines across, again, kind of imagine that if you had a line that was actually increasing, I'd say, okay, the number of volumes in this particular group, if you will, is actually increasing for who knows what good reason. From this point, I'll be able to go to the actual current volumes on sync sort. And if I click on this, I'm actually looking at the point in time that we're keeping for the current TMC. And so I will see all the different volumes that actually are there and available. Almost done.
Kind of running a little bit short on time, Dave. We're going to have to wrap up here.
I'm trying to get through here real quick. Got this and then one more chart. I'm done.
Thinking pretty hard on this.
Oh yeah, it's more than a few volumes. But at any rate, it does show you now, here's the detailed specifics about that particular group of volumes. We're looking at the group Other. We're looking at the specific sync sort program name. And these are all the jobs that we know about, all the tape volumes that we know about in the TMC with that particular characteristic. So you can see that, for example, here's the creation dates, and some of them are quite old. Now, if it's not for permanent retention, in this case it says it is, but if it's really not permanent retention, certainly these would be candidates for scratching possibly. So that gives you an idea of some of the capabilities that we have in terms of the new TMC analysis that we make available.
Okay. Great. Thanks, Dave. Thanks, everybody, for holding on for us. We don't really have time for questions. I have just one slide here to wrap up on, helping you understand how you can get some more information. Obviously, these demos were only in a very narrow, specific context with specific hardware and type of problem. There's a lot of different white papers we have on our website, information on other aspects of reporting that we have. And of course, the easiest way is to do a customized demo for you, or even a proof of concept with our software as a service platform. It's very quick and easy for us to get some data from you, load it onto the platform, give you access to the web interface or the Windows interface or both, and walk you through what you can see in your environment that you haven't really been able to see yet with the automated warnings and intelligence and so on and so forth. So with that, I'll turn it back over to Jonathan to tell us about the conference.
Thank you very much, Brent, and the rest of the IntelliMagic team. That was a very interesting webinar. I really enjoyed it. Thanks also to all of our attendees who were able to join us. We hope you got some interesting information from that. The conference has been recorded. It'll be available at the CMG website later on this week. And just while I've got you on the phone, or on the webinar, I'd like to remind you that we've got the Cmg Impact Conference coming up November 6th to 9th, 2017 at the Loews New Orleans Hotel, right downtown in beautiful New Orleans. On November 5th, we'll have a hackathon on the Sunday. That's a new feature of Cmg Impact that we hope you'll be interested in. And for individuals who attended Cmg in the last 4 years, you should have received an email telling you about a special offer for a special, very low price for the Cmg Impact 2017 conference. If you've attended Cmg in the last 4 years and you didn't get your email, please get in touch with Michelle or Dave at Cmg headquarters. And again, thank you very much to IntelliMagic, to our Cmg staff, and to all of our attendees.
Okay, thank you, Jonathan. Thank you, everyone.